Today we're going to look at some percentage yield calculations. So it's predictable that if we do an experiment in the lab or if we look at a chemical reaction used in industry, that we won't get 100% yield. What we mean by that is we won't make as much of the intended product as we would predict if the experiment went perfectly. Often we need to initially calculate the predicted amount of any product and then compare this to how much was actually made. This is then presented as a percentage. This might make more sense if we look at an example. So, in an experiment to produce a sample of Hex1Ene, 10.2 grams of hexane was heated with an excess of phosphoric acid. The necessary parts of the equation are as follows. After purification of the Hex1Ene, 5.1 grams was produced. Calculate the percentage yield. So the first thing we need to do is calculate the theoretical yield. This is how much we would expect to make if the reaction was perfect, and this is much the same as our reacting mass calculations. So I take the two important chemicals from this equation. We have hexane and Hex1Ene. And I write down all the information that we're going to need. First of all, the mass in grams. And it tells us that we started with 10.2 grams of hexane. Then we can add in the MR value for hexane. If I look at this formula here, I see that we have 6 carbons, and if we look at carbon in the periodic table, we know that it has an atomic mass number of 12. So I do 12 multiplied by 6 plus 1 multiplied by 14. 1 is the atomic mass number of the hydrogen, and we have 14 of them, and then plus 16 for our 1 oxygen. This gives us 102. We can then calculate the number of moles. Moles is equal to mass in grams divided by the MR. So 10.2 divided by 102 gives me 0.1 moles. Now I need the ratio, and we can see from the equation given that our ratio is going to be 1 to 1. This means that if I had 0.1 moles of hexane, I will produce 0.1 moles of hexene also. Now I need to calculate the MR value of hexene. Again, 12 multiplied by 6. 12 for the atomic mass number of carbon, and we have 6 of them, plus the hydrogen atoms, and we have 12 of them. So 1 multiplied by 12, as 1 is our atomic mass number of hydrogen. This gives us a total of 84. Now I can work out the mass in grams by doing moles multiplied by the MR. So 0.1 multiplied by 84 gives me 8.4 grams. This is what we should get if our reaction was perfect. However, we're told that we actually only make 5.1 grams, and this is our actual yield. In order to work out the percentage yield, we have to do an extra part of our calculation. We take the actual yield, divide it by the theoretical yield, and multiply this by 100 to convert it into a percentage. So with our numbers, the actual yield that we calculated, the actual yield that is given is 5.1 grams. The theoretical yield which we calculated is 8.4 grams. If I divide 5.1 by 8.4, we get 0.607. I then need to multiply this by 100 to give me a percentage, which gives me 60.7%. And this is our percentage yield. If this was a multiple choice question, they may give you the actual and the theoretical yields and ask you to calculate the percentage yield. So you'd only have to calculate the last part of this calculation. Alternatively, they might give you a different combination of these numbers and ask you to find the other. For example, by telling you the theoretical yield and the percentage yield and then asking you to calculate the actual yield. But just look at what the question is asking and remember that this is the equation that you need to use. Now you can have a go at some yourself.